It's a series of videos, calculus videos that are part of a workshop, and it's called sometimes called maximum or minimum calculus, or looking at optimization. You're looking for the biggest or the smallest, the value that will give you the biggest or the smallest, sometimes area, sometimes volume. Okay, so anyways, in these max min problems, what they do to you is they give you a story, and sometimes you have to make a sketch, and then you have to use variables to represent the unknowns on the outside of this. Maybe it's a rectangular box, or maybe it's a cone, or a cylinder, something like that. Then you have to make an equation. Okay, so you have to build the volume or build the surface area, and that equation has to be in one variable. Otherwise, your derivative thing won't work. So you've got to get everything in terms of x, the width, uh, or something like that. And I'll show you how it works in just a sec with an easy example. Well, after you've got the formula, once you've got the equation, you've got to find the derivative of that equation. Okay, derivative of it. And then to find the max and the min, just like you would with a cubic function or something, you let the derivative equal zero. You find out where the gradient, the tangent, is zero. And then you solve that equation, and you'll end up with your local maximum or minimum. You'll end up with a solution to the question. Well, let's just start with a pretty easy question. You've got here you're given a box, and it looks like that this base is x, and looks like the height is x. This one side here is 60 minus x. Well, the first thing they might say is show that the volume of the box is 60x squared minus x cubed. Well, volume is just multiply all three sides together, so that's what you do. Width times length times depth. So the volume function is just x times 60 minus x, okay? Well, and that's how we get 60x squared minus x. There's your volume, okay? Actually, I should have put it a little bit, we need that equation down there. Anyways, there's the volume. You multiply it out, and it equals 60x squared minus x cubed. Well, the next step is you find the derivative. Just go the derivative of 120 and 3x squared. You're going to get 6x, 120 minus 6x. But then, you know what I did is I divided everything by 3, so I get 40x minus x squared. Then I factor out x, and hey, I'm looking at the two things that will make it equal to 0. 0 or 40. Well, 0 is not very helpful. That's not going to maximize the volume. But 40 turns out to be your answer. 40 centimeters is the width and the height of this box here, or the width and the length, I guess you could call it, if this is the depth. That's what x has to be. And then the question is determine the maximum volume. So you take this 40 and you put it into the formula, and you press the buttons on your calculator, and you get 32,000 cubic centimeters. Well, 1,000 cc's is a liter, so it must be 32 liters is the maximum volume that you can get. And that's it. That's the first one. The first question that we do in the workshop. We'll try the second one in just a bit.